The universe is a grand theater. Its stage is dark, vast, and seemingly endless. Across this cosmic expanse, countless stars ignite the darkness. They are the storytellers of the cosmos. Each point of light we see in the night sky is a distant sun. Some are like our own, calm and steady. They burn for billions of years, providing warmth and light to the worlds that circle them. These stars are the quiet, dependable characters in the cosmic play. They live predictable lives and die in gentle, quiet ways. We look up and see them as pinpricks of peace, a beautiful, unchanging tapestry woven across the heavens. But this familiar peace is only one part of the story. The universe is not always quiet. It is also a place of unimaginable violence and power. It is a realm of extremes. Out there in the deep, dark spaces between the gentle stars lurk true monsters. These are not the calm, steady suns we know. They are cosmic titans living fast and furious lives. They are born from chaos and destined for explosive ends. Their existence is a testament to the sheer scale and raw energy of the universe, a reminder that the cosmos is wild, untamed, and full of incredible surprises. These cosmic giants are magnificent and terrifying. They are the rock stars of the stellar world. They burn brighter than millions of our suns combined. Their surfaces are cauldrons of nuclear fire, hotter than anything we can truly comprehend. They don't just shine, they rage against the darkness. They live their lives on the edge, pushing the laws of physics to their absolute limits. Understanding these titans is crucial. It helps us understand the universe's most dramatic events. It helps us piece together the story of how everything we see came to be, from the dust between stars to the very planets we walk on. So let us journey together into this wild frontier. Let's look past the quiet, familiar stars. Let us venture into the heart of cosmic storms where giants are born and die. We will explore a category of stars so extreme, so powerful, that it defies easy explanation. These stars are rare, beautiful, and incredibly violent. They are the universe's ultimate rebels, tearing themselves apart in a spectacular display of power. They are known as Wolf-Rayet stars. What exactly is a Wolf-Rayet star? Imagine our sun, a familiar, life-giving star. Now, imagine a star that is vastly different, a star that is 20 times more massive, or even more, a star that shines with the light of 100,000 suns. A star so hot, its surface burns at temperatures of over 30,000 degrees Celsius, and sometimes much higher. This is the realm of Wolf-Rayet stars. They are not like the common stars that dot our night sky. They are a special class of stellar behemoth, a fleeting and violent phase in the life of the most massive stars in the universe. These are not newborn stars, nor are they ancient relics. They represent a dramatic transition. They are massive stars that have reached a critical point in their evolution. They have already burned through the hydrogen fuel in their cores. Now they are fusing heavier elements like helium, carbon, and oxygen. This process unleashes enormous amounts of energy. This energy is so intense that it pushes the star's outer layers away. A Wolf-Rayet star is in essence a star that is actively shedding its own skin. It is revealing its hot, dense core to the cold vacuum of space. The name itself, Wolf-Rayet, comes from the two French astronomers who first discovered them. In 1867, Charles Wolf and Georges Rayet were observing the sky from the Paris Observatory. They noticed a few peculiar stars with very unusual spectra. Instead of the typical dark absorption lines seen in most stars, these showed bright, broad emission lines. This was a puzzle. It meant these stars were not just passively shining. They were actively throwing off vast amounts of glowing gas. This discovery opened a new window into the lives of the most massive stars, revealing a phase of stellar life that was more chaotic and powerful than anyone had imagined. This intense process of shedding mass is what defines them. A typical star like our sun loses a tiny fraction of its mass over its entire lifetime through a gentle solar wind. A Wolf-Rayet star does something far more extreme. It blasts its own substance into space at an astonishing rate. It can lose the equivalent of our sun's entire mass in just a few 100,000 years. This is not a gentle breeze. It is a cosmic hurricane, a furious, unending storm of stellar material traveling at millions of kilometers per hour. This is what makes them the monsters of the cosmos. What truly defines a Wolf-Rayet star is a process we could call a stellar striptease. It's a star that is systematically shedding its outer layers, revealing the hotter, deeper layers beneath. But this isn't a gentle process like our sun's solar wind. It's actually an incredibly violent and rapid expulsion of mass. This fierce stellar wind is driven by the intense radiation pouring out from the star's core. The light is so powerful that it literally acts like a physical force, a continuous punch that shoves the star's own atmosphere out into space. This is a star that is quite literally blowing itself apart over time. The most striking feature of a Wolf-Rayet star is its wind. This is not wind in the earthly sense. It is a torrent of charged particles, a river of plasma flowing from the star's surface. This stellar wind is incredibly powerful. It is thousands of times stronger than the wind from a normal star. It moves at incredible speeds, often reaching over 2,000 kilometers per second. At that speed, you could travel from London to New York in just a couple of seconds. This relentless outflow of matter is what creates the bright emission lines that Wolf and Rayet first saw. The gas is so hot and moving so fast that it glows brightly. These winds have a profound impact on the space around them. As this high-speed material slams into the slower-moving interstellar gas and dust, it creates magnificent structures. It carves out huge bubbles and shells in the interstellar medium. These bubbles can be dozens of light-years across. They are often filled with intricate filaments and glowing shock waves. The winds enrich the surrounding space with heavy elements like carbon and oxygen, which were forged deep inside the star's core. These elements are the essential building blocks for future generations of stars, planets, and even life itself. Imagine you are an astronomer in the 19th century. You spend your nights gazing through a telescope, mapping the heavens. You believe you have a good understanding of what stars are. They are distant suns, great balls of hot gas shining with a steady light. Then one night you find something completely unexpected. You point your spectroscope, an instrument that splits starlight into its rainbow of colors, at a seemingly ordinary star. But what you see is not ordinary at all. Instead of the familiar dark lines of absorption, you see bright, bold lines of emission. This is precisely what happened to Charles Wolf and Georges Rayet in 1867. They had stumbled upon a new kind of cosmic beast. These emission lines were a profound clue. They told a story of a star behaving in a way no one had seen before. A normal star's atmosphere absorbs certain colors of light, creating dark lines in its spectrum. This tells us what elements are present in its cooler, outer layers. But these new stars showed the opposite. The bright lines meant that vast clouds of gas were being heated to incredible temperatures and were glowing intensely. This gas wasn't quietly sitting in the star's atmosphere. It was being violently ejected, thrown outwards into the void of space. The exposed core of a Wolf-Rayet star is an extraordinary place. It is a nuclear furnace of unimaginable intensity. Temperatures soar to tens of millions or even hundreds of millions of degrees. Here, the fundamental building blocks of matter are being forged. While our sun is busy fusing hydrogen into helium, a Wolf-Rayet star has moved far beyond that. In its core, helium atoms are being slammed together to create carbon. Then, carbon and helium are fused to create oxygen. This process, called nucleosynthesis, continues to build heavier and heavier elements, creating a layered, onion-like structure deep within the star. These heavy elements don't stay locked inside the star forever. The powerful stellar winds, which are stripping the star's layers away, carry these newly forged elements out into the galaxy. A WC-type Wolf-Rayet star, for instance, is essentially a giant carbon and oxygen factory, spewing these vital elements into the interstellar medium. The carbon that makes up the trees on Earth, the oxygen we breathe, and the elements that form the very fabric of our bodies were all created inside stars like these. Imagine standing on a planet orbiting a Wolf-Rayet star. It would be a terrifying experience. The sky would be ablaze with a light brighter than 1,000 suns. But honestly, the light is not the most dangerous thing. The real threat is the wind. This is not a gentle breeze that rustles leaves. This is a hurricane of starlight, a relentless blast of particles moving at unimaginable speeds. The stellar wind from a Wolf-Rayet star is one of the most powerful forces in the known universe. It's a continuous explosion, a star actively tearing itself apart and flinging its substance into the void. This is power on a scale that dwarfs anything we know on Earth. This wind is born from the star's incredible luminosity. A Wolf-Rayet star is so bright, its light actually exerts a physical push. This is known as radiation pressure. The photons, the very particles of light, stream away from the star's core with such intensity that they act like a sandblaster. They catch the atoms in the star's outer atmosphere and accelerate them to incredible velocities. We're talking about speeds of millions of kilometers per hour. This isn't a slow evaporation. It's a violent expulsion. The star is shedding mass at a rate that is truly mind-boggling, losing more material in a single year than our sun does in 10,000 years. The incredible winds from Wolf-Rayet stars do not simply disappear into the vastness of space. They are powerful cosmic sculptors. As this torrent of high-speed material plows through the galaxy, it slams into the surrounding interstellar medium, the thin mixture of gas and dust that lies between the stars. This collision is not gentle. It is a cataclysmic event that carves out enormous structures in the fabric of the cosmos. The wind acts like a snowplow, pushing and compressing the interstellar gas into vast expanding shells. These structures are known as stellar wind bubbles, and they are beautiful testaments to the star's power. These bubbles can grow to enormous sizes, often spanning tens of light years across. That is thousands of times larger than our entire solar system. From our telescopes, they appear as faint glowing nebulae, often with delicate, intricate shapes. A famous example is the Bubble Nebula, NGC 7635. At its heart sits a Wolf-Rayet star, whose ferocious wind has inflated a nearly perfect spherical shell of gas. Another is Thor's helmet, a nebula whose shape uncannily resembles the winged helmet of the Norse god. When the wind from a Wolf-Rayet star collides with the surrounding interstellar gas, it creates a phenomenon known as a shockwave. This is similar to the sonic boom created by a supersonic jet, but on an astronomical scale. It is a boundary where the physical conditions, temperature, pressure, and density change dramatically and violently. The gas is heated to millions of degrees, causing it to glow brightly in X-rays and other forms of light. This is the glowing edge of the stellar wind bubble, a luminous scar marking the battlefront between the star's outflow and the galaxy's quiet gas. It's a symphony of cosmic violence. These shockwaves are not simple, smooth surfaces. They are turbulent and chaotic. The collision is unstable, leading to the formation of intricate filaments, clumps, and arcs of glowing material. When we look at images of nebulae around Wolf-Rayet stars, like the stunning Crescent Nebula, we are seeing this complexity firsthand. The delicate, wispy structures are regions where the shockwave is interacting with denser patches of interstellar gas, creating a beautiful and complex tapestry of light. It is a visual record of an ongoing cosmic collision, a process of immense energy release playing out over thousands of years. The energy released in these shocks is immense. It can be a major source of heating for the interstellar medium in a galaxy. The wind from a Wolf-Rayet star is more than just a powerful force. It is a vital delivery system. It is a river of freshly forged elements, flowing from the heart of the star out into the cosmos. As the star blows away its outer layers of hydrogen, it exposes the deeper layers where nuclear fusion has created heavier materials. First, we see the products of hydrogen burning, like nitrogen. Then, as more layers are stripped away, we see the products of helium burning, a flood of carbon and oxygen. The wind is a direct sample of the star's core, carrying the building blocks of life into the galaxy. This process of chemical enrichment is fundamental to our existence. The early universe contained only the lightest elements, hydrogen and helium. Every heavier element, everything that makes up rocky planets, atmospheres, and living organisms, had to be created in the hearts of stars. Wolf-Rayet stars are some of the most important factories for these elements, particularly carbon. A single carbon-rich Wolf-Rayet star can enrich its local neighborhood with more carbon than thousands of sun-like stars could over their entire lifetimes. They are profoundly efficient at seeding the cosmos. When these elements are carried away by the wind, they mix with the interstellar gas and dust. This enriched material then becomes part of the next generation of cosmic creation. The story of a Wolf-Rayet star does not begin with its own fiery birth. It actually begins much earlier, with the birth of a true cosmic giant. To become a Wolf-Rayet star, a star must start its life with immense mass. And we're not talking about stars just a little bigger than our sun. We're talking about the true heavyweights of the universe, stars that are born with at least 25 times the mass of our own sun, and sometimes much, much more. These stellar titans are born from the collapse of vast, cold clouds of gas and dust. They are rare, forming only in the most active and dense star-forming regions of a galaxy. From the very beginning, their destiny is set for a short and spectacular life. These massive progenitor stars are known as O-type stars. They are incredibly hot and luminous, shining with a brilliant blue-white light. They burn through their hydrogen fuel at a furious pace, living for only a few million years. This is a mere fraction of the 10 billion-year lifespan of a star like our Sun. During this initial phase, they already possess powerful stellar winds, but these are nothing compared to what is to come. Their immense gravity holds them together as their cores rage with nuclear fire. Deep inside, hydrogen is fused into helium, building up a core of waste material that will fuel the next, even more intense stage of their lives. This is the quiet before the storm. The Wolf-Rayet phase is the shortest and most dramatic part of a massive star's life. It's a fleeting moment on the cosmic timescale, lasting for just a few 100,000 years. For comparison, the dinosaurs roamed the Earth for over 150 million years. The entire existence of a Wolf-Rayet star is a mere blink of an eye in comparison. Yet in this short period, the star undergoes the most profound changes. It is a star in a hurry, burning through its remaining fuel at an astonishing rate while simultaneously blasting its own substance into the void. It's a life lived at maximum intensity, a brilliant flame burning twice as bright, but for only a fraction of the time. During this phase, the star's internal structure is like a cosmic onion. At its heart, the core is fusing helium into carbon and oxygen. In more massive Wolf-Rayet stars, this process continues, creating even heavier elements like neon, magnesium, and silicon. Each new fusion stage releases tremendous energy, but provides less fuel for the star's furnace. The star is in a desperate race against gravity. The outward push of radiation from the nuclear reactions is all that prevents the star's immense mass from collapsing in on itself. As a Wolf-Rayet star continues to burn through its fuel, it approaches the end of its life. The nuclear fusion in its core creates progressively heavier elements, culminating in the production of iron. This is the point of no return for any massive star. The fusion of iron does not release energy, it actually consumes energy. The moment an iron core begins to form, the star's fate is sealed. The outward radiation pressure that has supported the star for millions of years suddenly vanishes. The furnace at the heart of the star has gone out. The final countdown has begun, and it will be over in a matter of seconds. Without the outward push of fusion, gravity wins the battle. The star's core, which can still be more massive than our entire sun, collapses catastrophically. In less than a second, a region the size of the Earth implodes to become a dense ball just a few dozen kilometers across. The infalling material smashes into this newly formed, incredibly dense object and rebounds, creating a titanic shockwave. This shockwave blasts outwards through the rest of the star, tearing it apart in one of the most violent events in the universe, a supernova explosion. For a few weeks, the dying star can outshine its entire host galaxy. After the brilliant light of the supernova fades, a mysterious and enigmatic object is often left behind. The collapsed core of the Wolf-Rayet star, the very heart of the former Titan, remains. If the original star was massive enough, even after blowing away its outer layers and exploding as a supernova, this remnant will be too heavy to stabilize as a neutron star. Its own gravity becomes overwhelmingly powerful, crushing it beyond all known limits of physics. Nothing can halt its final collapse. The core implodes into an infinitely dense point, a singularity, tearing a hole in the fabric of space-time itself. In the place of a brilliant star, there is now a stellar mass black hole. This is the ultimate legacy of the most massive Wolf-Rayet stars, the birth of darkness. A black hole is a region of space where gravity is so strong that nothing, not even light, can escape. It is the ghost of the star that once was, an object defined by its sheer gravitational presence. The Wolf-Rayet star, which spent its life pouring light and matter out into the universe, ends its existence by creating an object that does the opposite, a one-way door to oblivion from which nothing returns. The legacy of a Wolf-Rayet star does not end with its supernova or the creation of a black hole. Its influence continues to echo through the cosmos for millions of years. The expanding supernova remnant, a beautiful and intricate web of glowing gas, carries the star's final elemental gifts far and wide. This bubble of enriched material gradually mixes with the surrounding interstellar medium, fundamentally and permanently changing the chemical composition of that region of the galaxy. Future generations of stars that form from this material will have a higher concentration of heavy elements, making the formation of rocky planets more likely. The star's ghost continues to shape the potential for life long after it is gone. These echoes can also be heard in another, more exotic way, through gravitational waves. The violent core collapse of the supernova, or the potential merger of a Wolf-Rayet star's remnant black hole with another compact object, creates ripples in the very fabric of space-time. These gravitational waves travel outwards at the speed of light, carrying information about the cataclysmic event that created them. Observatories like LIGO and Virgo have detected such waves from merging black holes, some of which are thought to have originated from massive stars like Wolf-Rayets. This opens a completely new window onto the universe, allowing us to hear the echoes of these titans' deaths. Looking beyond our own galaxy, the cumulative effect of countless Wolf-Rayet stars over cosmic history has been profound. We have journeyed to the most extreme frontiers of the stellar world. We have met the titans of the cosmos, the Wolf-Rayet stars. These are not merely distant points of light. They are furious engines of cosmic change. They live lives of unparalleled intensity, burning brighter than 1,000,000 suns and tearing themselves apart with winds of unimaginable power. Their story is a dramatic tale of transformation, a journey from a massive, brilliant blue star to a stripped-down core raging against the dying of its light. In their brief, violent lives, they offer us a unique window into the most fundamental processes that govern our universe, from the creation of elements to the birth of black holes. Understanding these stellar behemoths is not just an academic exercise. It is essential for piecing together our own cosmic origin story. Wolf-Rayet stars are the great alchemists of the galaxy, the primary forges where the vital element of carbon is created and distributed across space. The very atoms that form our planet, our atmosphere, and our bodies were likely cooked in the heart of a star like this and scattered by its ferocious winds or its explosive death. To study a Wolf-Rayet star is to look back at our own chemical ancestors, to witness the process that made a universe capable of harboring life possible in the first place. They are a direct link in the chain connecting the Big Bang to our existence today. Our exploration of these cosmic monsters is far from over. In many ways, we are just beginning to unravel their deepest secrets. Each new observation, each more powerful telescope brings new questions and fresh mysteries. We have identified hundreds of these stars in our galaxy, but we suspect many more lie hidden, shrouded by dense clouds of gas and dust. Future missions, equipped with advanced infrared and X-ray detectors, will peer through these cosmic curtains, allowing us to build a more complete census of these stellar titans. This will help us to better understand their populations, their life cycles, and their true impact on the galaxy. The advent of gravitational wave astronomy has opened a completely new frontier. We can now listen to the echoes of the universe's most violent events. The merger of black holes, some of which are the remnants of Wolf-Rayet stars, sends ripples through space-time that we can now detect on Earth. These detections provide a novel way to study the end states of these massive stars, offering clues about their mass, their spin, and the cataclysmic events that marked their demise. The story of Wolf-Rayet stars is ultimately a story of inspiration. It reminds us of the vastness and wonder of the universe, and of our own persistent drive to understand it. These wild, untamed stars, raging against the darkness millions of light-years away, spark our curiosity and fuel our quest for knowledge. They are a powerful symbol of the cosmic cycle of life and death, and a profound connection to our own origins. As we continue to gaze out into the deep, we will continue to learn from these stellar giants, forever drawn to the beautiful, violent, and magnificent mysteries they represent. The journey has just begun.